In Lesson 3, we want to talk about solving equations with special solutions and solving literal equations. Up until now, whenever we've solved our equation, we've come out with a specific value for x. There are special cases, and pause and think about what the word special means, like a special occasion. You're right, it's an occasion that doesn't happen very often. So there are special cases where when we solve an equation, we don't get a specific numerical solution like x equals 5. This is going to occur when the variable cancels out during the solving process. We will end our problem with a statement that is either true, like 4 equals 4, or false, like 4 equals 5. When these cases happen where we have a special solution, that solution will either be all real numbers, and you can also represent that with the capital R with 2 lines, the real number symbol, or we have no solution, which is a circle with a line through it. You can use either one of those. So when we solve, the variable happens to disappear. If we're left with a true statement, then we are going to say that we have all real numbers. What that means is that I can pick any value for x and plug it in, and the left-hand side and the right-hand side will always be equal to each other. If we solve and the variable disappears and we are left with a false statement, then we are going to say that there is no solution to our problem. What that means is it doesn't matter what number I pick for x. Any number I plug in, I will find the left-hand side and the right-hand side will never be equal to each other. Let's try one. Thinking about our 6 steps, in the first problem, we are going to start by distributing. The left-hand side is going to stay the same, and the right-hand side is going to become 2x plus 4. Continuing with our steps, there are no fractions or decimals to eliminate, and there are no like terms over here or over here to combine. So we move on to addition or subtraction. I know that 2x and 2x are both like terms and that I want to ultimately combine them together. So I'm going to take this 2x and move it over here. 2x and negative 2x cancel, and I'm left with 4 on the right-hand side. Uh-oh, 2x and negative 2x over here also cancel, and we are left with 4 on the left-hand side. Notice that in the solving process, my variables disappeared or canceled out. At the end of the problem, I was left with the statement that 4 equals 4. Since that is a true statement, then we are going to interpret that our solution is all real numbers. And you can either write it like that, or again, you may write the capital R for real numbers. Again, what this means is that I can pick any number in the world, plug it in for x, and the left-hand side and the right-hand side will always be equal. Let's try one. Let's suppose that I want x to be 10. On the left-hand side, 2 times 10 plus 4 comes out to be 24. On the right-hand side, 2 times 10 plus 2 also comes out to be, 24. Let's pick another number. Let's try a negative number this time. Let's suppose that x is negative 5. The left-hand side, 2 times negative 5 plus 4 becomes negative 6. And on the right-hand side, 2 times negative 5 plus 2 also becomes negative 6. Let me prove it one more way. Let's suppose that x was 1/2, so we'll try a fraction. 2 times 1/2 plus 4 makes 5. On the right-hand side, 2 times 1/2 plus 2 also makes 5. You see, it doesn't matter what we plug in for x, the left-hand side and the right-hand side will always be equal to each other. Therefore, we interpret that as all real numbers. Any x value will work. In the second equation, we will start with distributing. We're going to distribute the 4 on the left to get 4x minus 8 is equal to 4x. There are no fractions or decimals to eliminate, And on this side of the equal sign, there are no like terms to combine. And over here, all we have is a 4x. Thinking through our steps, we now want to add or subtract. So I want to get these 4x's together. I'm going to take the 4x from this side and bring it over to this side. These are going to cancel. 4x take away 4x leaves me with 0. Uh-oh. 4x take away 4x over here also canceled out to become 0. So the left-hand side is equal to -8. When I think about the statement -8 is equal to 0, that is false. -8 is not equal to 0. And so we interpret our solution here as no solution, or the circle with the line through it. Either one is fine. What that means is it doesn't matter what number I plug in for x, the left-hand side of the equation and the right-hand side of the equation will never be equal. Again, let's try 10. 4 times 10 minus 2 comes out to be 32. On the right-hand side, 4 times 10 is 40. 32 and 40 are not equal to each other. All right, let's try a negative number. 4 times -5 minus 2 makes -28. On the right-hand side, 4 times -5 is -20. Again, they're not the same. Finally, let's try a fraction. 4 times 1/2 minus 2 gives us -6. And on the right-hand side, 4 times 1/2 gives me 2. Again, -6 and 2 are not equal. So you'll see we've picked a lot of values for x, and in every case, the left-hand side and the right-hand side were never equal to each other. You try the last problem. I'm going to distribute. I am going to move the 4x over to the left. So -x plus 6 is equal to 7. Notice in this problem, my variables did not cancel out. This is more like the problems we've been working with. Move the 6 to the right. -x equals 1. And when I divide, I get a specific value for x. I see that x is equal to -1. Meaning that is the one and only solution I can plug in that will make the left-hand side equal to the right-hand side. Quick summary. We have 3 cases when we solve an equation. The first case is the one we've been working with the most often. When we solve, we may come out with a specific value for x, a single number that is the only number that can be plugged in to make the equation true. We could also have a scenario when we solve where our variables disappear and we are left with a false statement. In that case, we have no solutions. And our final scenario is that when we solve, our variables disappear, but we are left with a true statement. In that case, we will say that we have all real numbers. Again, in summary, all real numbers means you can plug any number in for the variable, and the 2 sides of the equation will always be equal. Whereas no solution means that there are no numbers you can plug in for the variable that will make the left-hand side and the right-hand side equal. Let's talk now about literal equations. A literal equation is an equation that involves multiple variables. Sometimes this is known as solving for a specific variable. You'll notice in examples 1 through 5, we have multiple variables in our problem. Our job is to solve the problem for the best variable that is specified. For example, in number 1, it asks us to solve for W. When it says in terms of P&L, that is a hint to you that P&L will still be in the problem. We're going to use our same 6 steps for solving. Remember, our goal is to isolate the indicated variable using our knowledge, our 6 steps of solving equations. So in number 1, I want to rearrange that equation to solve for W. In other words, I need to get that W by itself. Again, in terms of P and L, tell me that P and L will both still be in my problem. We're going to follow our 6 steps. In trying to solve for W, there is nothing to distribute. Next, we'll eliminate fractions or decimals. There are no fractions or decimals to eliminate. The next step is to move things over that involve to combine like terms. We don't have any like terms here. 2L and 2W cannot be combined because L and W are different variables. Now we will move things over by addition or subtraction. To get this W by itself, I'm going to have to get rid of the 2 that is in front of it, but also the 2L that is added to it. Again, addition and subtraction comes first, so I'm going to subtract the 2L on both sides of my equal sign. On the left-hand side, P and 2L are not like terms. So I am going to simply write this as P minus 2L. I cannot combine them. On the right-hand side, 2L and negative 2L cancel, and I'm left with 2W. Now we divide now we multiply or divide, and in this case, because it is 2 times W, we are going to divide both sides by 2. Over here, the 2's cancel to leave me with W all by itself. And on the left-hand side, I can see that W is equal to P minus 2L all over 2. The symmetric property says that I can rewrite that if it bothers me that the W is on the right and not on the left. So when we solve, W is equal to P minus 2L divided by 2. In other words, to find the width, I take the perimeter, subtract 2 of the lengths, and divide the entire thing by 2. In the second example, we have the formula for the area of a triangle. This time we want to solve for H in terms of A and B. This means that we want to get H by itself, knowing that A and B are still going to be in our problem. Thinking about our 6 steps, there is nothing to distribute. The next step says we should eliminate fractions and decimals. I have a fraction of 1/2, so I am going to multiply by the least common denominator. In this case, the only denominator I have is 2. I'm going to multiply the A by 2, but I am also going to multiply the 1/2 BH by that same 2. Guys, 1/2 BH is one term because that's all multiplication. Remember, I start introducing new terms when I see an addition or subtraction sign. All right, on the left-hand side, 2 times A gives us 2A. And on the right-hand side, I've got 1/2 times 2 times B times H. Well, half of 2 is 1, and 1 times B times H leaves me with BH. Our next step is to combine like terms. There are no like terms to combine. Then we would want to move anything over that involves addition or subtraction. Everything we have is multiplication. B is multiplying H, 2 is multiplying A. No addition or subtraction. So now we multiply or divide. If I'm trying to get H by itself, I need to get rid of the B. B is multiplying the H, so I'm going to divide by B. Those cancel, and I find that H is equal to 2 times A over B. Again, if it bothers me that that is written with the H on the right, I can rewrite it and say that H is equal to 2A over B. In other words, the height can be found by taking 2 times the area and dividing by the base. Number 3, I is equal to PRT is our formula for simple interest. Interest is equal to principal times rate times time. If I want to solve this for P, I'm going to think through my 6 steps. There's nothing to distribute. There are no like terms to combine. There's no fractions or decimals. There are no like terms to combine. There's no addition or subtraction. And so we're at multiplication and division. To get P by itself, it is currently being multiplied by R and T. To undo multiplication, we are going to divide. Divide this side by the R and T, and divide this side by the R and T. The R on top and the R on the bottom cancel. The T on top and the T on the bottom cancel. And so on the right-hand side, P is all by itself. And on the left-hand side, it is equal to I over RT. Again, symmetric property allows me to rearrange that P is equal to the interest divided by the product of the rate and the time. Number 4, we want to solve for x. X is currently located right here inside of these parentheses. So thinking about my steps, step number 1 says to distribute. So we are going to distribute. 3 times x is 3x, 3 times y is 3y, and that is equal to b. Step number 2, eliminate fractions or decimals. We have none. Step number 3, combine like terms. I cannot combine these two things because the variables don't match. Next step, move anything over by addition or subtraction. If I am trying to get the x by itself, I'm going to ultimately need to move this 3, which is multiplying the x, and I'm also going to need to move this 3y, which is being added. So step 1 there, we're going to get rid of the 3y. 3y and 3y cancel, so on the left-hand side, 3x is left. On the right-hand side, b and negative 3y are not like terms, so the best I can do is write it as b minus 3y. And finally, we finish our problem off with division. 3 is multiplying the x, so we're going to divide both sides by 3. And we find that x is equal to b minus 3y divided by 3. The last one's a little tricky. Notice that the variable that I want to solve for actually shows up in the problem twice. I have an a here and an a right there. Thinking back to when we did our algebraic proofs, we saw a couple of examples where we did what some of you described as undoing the distributive property. In other words, we took out what those two terms shared in common. Since both of these terms share an a, I can take the a out. And if I think about what I would need to multiply a by if I were going to distribute back in, a times what would make ax? X. And then if I were going to distribute here, a times what would make this ay? Y. Very good. All right. So we actually had to undo the distributive property here because we had 2 variables and we needed to get that down to just one variable that we can solve for. All right. There are no fractions or decimals. There are no like terms to combine. There is no addition or subtraction to move over because the a is multiplying the x plus y. Then to get a by itself, we would need to divide, because the opposite of multiplication is division. Divide by the quantity x plus y. So this quantity of x plus y and this quantity of x plus y cancel, leaving me a by itself over here. And on the right-hand side, we have that is c divided by the quantity of x plus y.